All right. So, hello to everyone there. If you could type in could you go in and change your name on your screen so that it reflects your real name, just for our tracking purposes for Renzi. And for those of you who absolutely have to remain anonymous, please just ignore that request. I know there are some of you like that. Okay, with that being said, it is my great pleasure to introduce you to our speaker today, Lingfei Wu, who's from the University of Pittsburgh and their School of Computing and Information. His work is distinct from a lot of the work we have heard so far because he's interested in the geometry of thinking. He himself is a computational scientist, and he applies this approach to the geometry of thinking to lots of topics. And one of those is, of course, debates and looking at how expert opinion kind of flows within and among the groups at this point. So with that being said, I'm going to turn it over to Lingfei. Lingfei?
Yep, thanks, Kelvin. I would like to thank Kelvin for organizing this great forum, and Michael Corrasi to recommend me for this opportunity, and Marianne, Nathan, and the other colleagues to coordinate this, and everyone from the same time space and different time space with us to participate. And so this is my topic. As Nathan pointed out, the background from the slide, you can see kind of what this is about, and half of the candidates are already out. So we are actually facing a very dynamic environment which pressing the importance of this topic. That is, can debate create knowledge? If yes, how? And what can we do to make it happen, to facilitate the knowledge creation, but rather just like locking everyone into the echo chamber or information, their own small little intellectual circle, this and that. So this is my general concerns, and I will start from a couple of examples we observe from the system in which we feel more comfortable to talk about what is knowledge and how knowledge created, and like science. And then like we will try to extend some of these insights, observations into more informal publications of Wikipedia, but still there's some institutional arrangement going on and very limited carry capacity for web pages. And also finally the social media, in which is even less rules and more information capacities. So, so first of all, I like to bring your attention to a recently published research by my coworkers, previous coworkers from Knowledge Lab at University of Chicago, leading by James Evans. And this paper is called "The Wisdom of Polarized Crowds," was authored by Bill Shi. So this is a very interesting paper to talk about knowledge and how that may relate to the polarization of crowds, because we typically think, there's a common belief that polarization is always bad, right? It always brings us with a negative consequence, is separating, dividing the country, dividing people, and creates more debate rather than just like being constructive. But is this always true? Is this always true? So one, in the research, if in the left side of the panel of the figure, you can see the distribution of how polarized these wiki users are by measuring their engagement to a fixed set of either liberal or conservative wiki pages. So if you are contributing to more liberal wiki page, then we'll put you in some kind of in some position in this spectrum. And if you contribute to more conservative page, we'll also do that. So this is from this you can map out the whole political tendencies or preference or tendencies of these wiki contributors. And from there, you can see, indeed, people are having very different ideas, including all the way to the left, which is like highly liberal, and all the way to the right, which is highly conservative, but also with a majority of audience or contributors lying in the neutral area, which is like near the zero values. So this is like all the editors and contributors of the Wikipedia wiki pages. And now the research question is, if we have a page, and as we all know, Wikipedia is an open platform, and that engage a lot of different contributions. People can talk to each other in the talk page. People can change each other's edits. People can make footnotes. There are all kinds of interactions going on, allow you to create or converge knowledge in the conversational way, right? So if we have a page and we treat all these people on contributing to the same page as the same team, and if we have a team that is more polarized rather than less polarized, so here like we can also talk about like the best term. You can call it polarized or like a fragment. Here in this research, there are not much detailed differentiations between those. So basically what we are talking about in quantitative way is basically like how much the contributors of this page are distributing on the two ends, left and right ends of the spectrum, rather than like concentrate on the middle. And how would this distribution affect the quality of the Wikipedia page? So the authors from this obtained a ground truth data, a ground truth like the data, coordinating with the Wiki Foundation research teams, and they have a machine learning model to extract the quality evaluation standards from crowdsourced ground truth data set, so that they can apply that to more than 400,000 wiki pages and give the quality score from that. And now we have the dependent variable as the quality score, or you can like, to make it more understandable, you can put it into different groups. So that's what you see from the right panel. You can you have a different quality of the wiki page ranging from all the way from stub to featured articles. And then you also have another independent variable, which is like how polarized or how different, how much variance within this, in terms of political preference, in terms of within this group of contributors. And very interestingly, we found that, they found that with more polarized crowd, even controlling other factors that you can think of, the number of contributors, the length of articles, and the number of edits, all these things, you still see a very significant positive correlation between polarization and quality of articles. So this point out a very interesting possibility over there, as these authors summarize in their article, that is polarization or is the difference of opinion always bad? What if, like in Wikipedia, we have very limited space, like virtual space, in the sense that, so this is a definition of democracy. You guys have to figure out a acceptable democracy, definition of democracy by yourself. So you have highly liberal people, have highly conservative people, but you need to discuss and formalize and structuralize and politicize and stabilize your idea on this page. Now, in this situation, you have people with energy. You have people who want to convince each other. You have people who want to contribute. So you have a lot of like passion and energy going on, but you also have a system in which people will coordinate. We have to come up with the result. We have, they will have different levels of editor to coordinate them. And maybe in this kind of scenarios, the debate is not always bad. It actually pushes forward the understanding of knowledge and the better definition and the more communication skills, like making metaphors and this and that, used to make the article itself more accessible to general audience, or like every footnote will be carefully checked by people with a different point of view of in terms of political spectrum. So all these things, maybe the complex landscape of the team composition probably will all contribute to actually the consensus and knowledge. So this is a very interesting finding, as I said in the background. Okay, so another finding about another interesting literature I want to point your attention to is from the Center of the Knowledge Lab, leading by James Evans, but published on American Journal of Sociology, called Ambiguity and Engagement. So this is, if the last research is talking about whether the engagement will create knowledge, then this article is looking at things from the other way. What kind of knowledge will further the engagement of discussion? So like engagement and knowledge, they're kind of like both of cause and consequence of each other, right? You keep people engaged. We have been engaging in creating knowledge in science for hundreds of years. Okay, so this is a very interesting article looking at two variables. One variable is word ambiguity. So now the word ambiguity, you can also call it word interchangeability or word substitution. That is to measure to what extent a word can be replaced by other words. For example, you can look at this kind of context and you will see like words like mechanical. It's used only in a very specific sense that it cannot be easily replaced by other words. But words like structure or other things, or like form or arrangement, states, these kind of words are more easily more possibly be replaced by other words. So the measure is if you find a certain word and you identify a small set of words with similar meanings that you want to observe or measure the interchangeability between these words, and then you select all the sentence to count the frequency at which among all these contexts, only one word or two words will be used highly frequently when other words are less likely, or the probability of using different words in the same context is almost uniform, like maximizing the variance and the entropy. So in the other, so if the word is using interchangeably with other words, then we call this word is like ambiguous word, because when author mention this word, the author may also mention other words used to express the same sense. But then if this word is only used so fixed within this kind of certain context, you cannot replace it by other words, then its law is less ambiguous. So this is the language ambiguity. And on the other hand, they measured the engagement. Like to what extent the following citations to the paper. So for the article, research article, you can already mention the average word language ambiguity. And then now you can measure to what extent the following articles or following authors, when they cite this article, do they also cite each other? So an easy way to understand is if you use very ambiguous words, like you like Confucius talking about love, or Jesus talking about love, then all these disciples will talk to each other. You're like, what did Jesus just said? What does he mean about love? What kind of context does this apply? There are probably like 10 different versions of explanation from different disciples. Then like they have to cite each other to confirm each other. But then this process is also like create some kind of engagement. So by measuring to what extent the following articles either only cites the original article and forming different branches, which is like low entropy and the low engagement, all the way to the right paradigm that all the foreign citations also cite each other, crossing each other, not only creating branches, but also breaking these branches and clusters and fragments. Then it's a high engagement. So you can use these to measure out these two kind of situations. And turns out these two variables are highly correlated. They're highly correlated. When you are using very ambiguous words, you create an environment that allows competing interpretations come into the conversation, and it actually stimulates and motivates social learning because people want to know what just happened and want to know what either Jesus, either Confucius, either Max Weber just said. So they have to keep citing from each other, keep the discussion going on. So eventually you actually also very ironically, by talking about things unspecifically, creating uncertainty, you actually also push forward the knowledge of learning. So that's putting together this versus previous research, we see a very interesting picture that having people have a different opinion with you is not always a bad thing. Maybe it could be the cause of knowledge that you will keep engaging in a debate, and then also another thing is if in the production of knowledge itself, not converging too much early, maybe not always a bad thing. People will have different ideas. People probably have different competing interpretations of the same terms, or they use terms differently. Then this kind of thing is not special, of course. You cannot write down things very quickly on the textbook, of course. But then this kind of situation also create an open environment for future engagement. So this is a very interesting tool research talking about the cause and consequence between knowledge and the conversation. And before I jump to the next study, which is more related to my own study, I like to point your attention that is not highlighted by the authors in these two research. That is the difference between soft knowledge and hard knowledge. And I really want to invite you to collectively think about this situation, that when we talk about knowledge, what kind of knowledge are we talking about? And when we talk about debate and push forward understanding, in what situation may that happen more efficiently rather than less efficiently? Okay, so one observation you can jot from this ambiguity and engagement paper is that if you look at the average language ambiguity across fields, all the way from, that's what you can see from the lower panel of these slides, all the way from humanity, law, mathematics, interestingly, and all the way down to physics, science, social science, agriculture, chemistry, biology. Of course, there must be the better way or less depending on the data set and everything and the measure. But you can see the general trend. If we have to divide this into a binary situation, we can see that in soft science, the words are more ambiguity used, like in humanity, right? And in general, in hard science, in empirical science, in science involves more equations, measuring devices, experiments, data, that if we naively call it hard science or hard knowledge, then the words are used more specifically. This is very understandable because when we talk about Newton's equation, when we talk about gravity, when we talk about relativity theory, when we talk about quantum physics, it's well defined. You cannot just change the name of gravity and talking about the gravity of your, I don't know, your heart to comfort food, right? You can use it in a daily context, but you cannot use it in the research article context. But in sociology, in humanity, it's less fixed. The knowledge is more fluid. Like you can use words in different words to express the same complex meaning. And if we review this article, the first article I mentioned, you also see this kind of difference. So if we observe and acknowledge the positive correlation between the polarization and quality. Then are those correlations strong or weak across different kinds of knowledge? Maybe yes. We see the significant difference here that this kind of debate and discussion is more pushing for, is increasing the knowledge quality of, at least article quality of political of politics and social science and the social issues more rather than science. So it looks like in terms of political issues, in terms of social issues, we want more debates. We want more debate to push forward to at least have a more higher quality of understanding so that we can talk more rather than in science. So this is an interesting finding I draw from their context, which I unfolded a little bit in my explorations of knowledge and also try to discuss use it as a context of studying debate in science. So allow me to use one more slide to talk a little bit more about soft knowledge and hard knowledge and what alternative measures of these two kind of things, so we can build up a deeper understanding and a bigger picture, right? If I may naively summarize soft knowledge as something like context-based, it's very hard to move across time and space. What we are talking about now is soft knowledge. Can debate push forward knowledge? That is the soft knowledge. Because I can't just show you one equation like gravity law and have a highly certain answer for all of you saying yes or not. We can point out some suggestive possible understandings, but it's very hard to write it down as code or write it down as equation so you can take that away with you. It doesn't move. It doesn't move easily or cheaply. It cannot be moved easily and cannot be scaled up easily. So we have to have this webinar, have this video, and in a better situation, we need to get a coffee and sit down and talk in person about this complicated situation, right? Because this is very complicated and it's very context-based. In the other end, if we talk about hard knowledge, it's context irrelevant, which means that you can codify that, you can crystallize that, you can stabilize that, and you can write down as textbooks, in textbooks, in equations, in codes, and you move that, you take that away with you across time and space. So you don't need to cite Newton anymore because everything you need to know about Newton is in the modern textbook of physics. But you probably still need to cite, I don't know, Confucius, the book by the disciple of Confucius again and again. You need to cite the Bible again and again. Why? Why there's no such thing about like textbook or Bible in the standardized knowledge in such a way that you don't need to refer to Bible again? Because the knowledge in Bible is soft knowledge. It's not like gravity. It's very context-based, and you have to always go to the context. You actually have to review the context to really understand what Jesus means and what Jesus really said, right? So these are other two alternative measures that I want to present to you. One measure is like, now we know soft knowledge is expensive to supply, means that it cannot be easily scaled up. It takes many minutes, many hours, many days to communicate, to discuss this kind of expensive issues and topics, to have a student like leadership, to have a student like know how to negotiate. So to supply this in institution, it's expensive. You need to hire good faculties with rich experience. So one assumption we can make about that is if soft knowledge is expensive to supply, then if we do the correlation between the discipline ranking versus the college ranking, which on the x-axis, which is highly dependent on the available research resources like money resource, space resource, and whether you are close or near to the culture and the intellectual center of urban cities, this and that. These kind of things will determine the general ranking of a university, right? You have these top universities, Harvard, Oxford, all these universities. So the axis now really kind of is an index of like how much resource you have and how much expense. I mean, it's also like you can see that how it directly relates to the tuition fee you need to pay to get in these kind of institutions. Now, then like you have, you can have the discipline ranking, either it's communication, either it's sociology, either it's political science, or it's engineering, physics, mathematics, computer science. And then here what I did is I analyzed their correlations and separated into 4 groups. And now you have, you can see directly like in more soft knowledge domains, the knowledge is, the correlation between these two is high. You have a high Pearson correlation. Sorry, I think the Spearman correlation is used here. And like in the more like hard knowledge in mathematics and physics and the computer science, you have a low correlation. That's because these kind of knowledge are easier to move. Then you can build a good mathematics program without spending with like all the physics or engineering program without exhausting a lot of resources. So this is one way to measure that. And the other way is a very interesting line of research from the inevitability of science. So this is like one interesting paper I want to point your attention to is Merton's paper in '60s about multiples and singletons. So basically the question asked here is, to what extent is science inevitable? Because, so how to measure that? One way to measure that, if science is highly inevitable, then almost every scientific discoveries have their alternatives. Like if Einstein never come up with the relative theory, then there will be other people come up with similar things. They have their duplications, they have their alternative copies. So if we lost this copy as a human society, we still have another one. So there are 2 pioneering work done by Merton in 60s and Ogburn and Thomas in 20s, is that they collect the whole list of discoveries and calculate the probability distribution of number of multiples, which means like for this certain invention or discovery, how much copies they have, or like how much people claim to come up with this discovery or invention independently without coordinating with each other. And a very interesting thing you can see like is like a lot of inventions and discoveries are multiples, which means that they are not so unique. And then they are also concentrated in time. That is, in the earlier decades, in the earlier centuries, most of multiples of scientific discoveries and inventions will be claimed within 10 years, like 70% within 10 years, and 30% maybe within 1 year. And people also find that this is accelerating now. People are like coordinating and synchronizing. And if you don't claim your scientific discoveries immediately, then after a couple of weeks, maybe some other people will claim it. That's why we are also anxious as a scholar, right? And a very interesting thing based on this measure is like, if there's a distribution, like if we model the distribution as a Poisson distribution with a mean value of mu that's characterized to what extent on average invention or thinking or idea or discovery will have a copy, then this value is if it's large, like greater than 1, then it means you always have a like alternative copy. When it's smaller than 1, means it's more like unique. And you'll find that hard knowledge, hard disciplines like mathematics, this value is larger. And then for biology, which is like more context-based fields, it's smaller. So which means like if we put it in a naive way, it's fields like hard knowledge fields like mathematics is more like inevitable. If you don't come up with this proof, other people will come up with this proof. But then like biology is probably less predetermined, less inevitable. So this is another perspective to look at soft or hard knowledge, rather than not just like the cost, but also the alternatives. Okay, so sorry for the long narrative, but I really want to engage you in this like very interesting context that I'm living with, and then I can share with you a little bit preliminary findings that what we do to relate, to associate debating and novelty. So we are we are building our work from a great paper by the group of leading by Dan Jarofsky from Stanford. And so what they are doing, as you from the left figures, you can see that they people have been analyzing citation a lot, right? We always assume that citation is some kind of endorsement, although we know it by our heart it is not. Especially in humanity and social science, many times we cite people to debate, to disagree, right? So in their pioneering research, they try to have a machine learning model to identify the function of citation. As you can see from these bars, a citation, and also from the 3 examples from the context they provided, you can cite something or someone to contrast, to compare. Or you can cite someone to use, to build your research upon. Or you can cite someone as shedding lights on the landscape, the environment. So cite as a background. Also, you can cite to show that your research is cite as a motivation, cite as extension, cite as future work, that kind of thing. So you have different kind of functions from the citation if you look into the context, but not just count the numbers, not just count the length of the reference list. You really can specify why people are citing this literature or citing this scholar for. Right? And but based on this machine learning model, they can identify the functions, and they have some interesting observations, like from formal publications like journals all the way to informal publications like workshops. People are talking more about what we are thinking as a convention, like you cite as a background, to what I am doing as an author to cite as uses. And also they analyze a main conference, ACR in the computational linguistics in the past decades, and they found that more and more people are citing for use. Less and less people are citing for compare and construct. So at least in the field, they were observing science is getting more practical and less debatable. People don't want to debate, people don't want to compare, people don't want to challenge each other. People just want to have one more piece to extend a little bit, to build a little bit, to use it a little bit. They are more like engineering style rather than like refractive style going on, at least in computer science, in one domain they are observing. And what we are using then, machine learning model for, actually we did a little bit of revision, including the neural network based, and we included a new model called transformer in terms of to improve the performance. But I will leave these technical details on the back. And well, after we improve that citation function identifying machine learning model, we use it to analyze whether debates in science also contribute to novelty. That's one dimension of knowledge we define and we care about. That is, so basically we can select the set of article, and then we can separate them into based on the because in computer science, the publication venue as a conference is the most important. So for example, we can select literally the most important conference in computational linguistics. One is ACL, which is more like, sorry, I think I made a wrong, the annotation is right. So ACR is more context irrelevant because it's more about the general rules of algorithms. It's more like hard knowledge. And then like the other like EM, MP, NLP, the EM is literally for empirical methods. So it's for more like context relevant, more domain specific, more applied consequence of computational linguistic models rather than the theoretical discussions. So we want to ask the question is, one, are debates good to new knowledge? Two, if yes, then in soft or hard knowledge, which is more important for debate going on? So for the first question, our answer, or at least at a suggestive level, is yes. We observe the universal correlation between to what extent this article is using citations, is citing for compare, challenge, and debate as an X, as you can see from the axis, and the performance variable or the dependent variable in the way that to what extent the important keywords identified by TF-IDF, which is like a search engine index to locate unique representative keywords for abstract, to what extent these kind of keywords for abstract are more novelly combined rather than conventionally combined. So it's like, it's a measure of, is this article talking about something new, some new associations between important things, or some some combination of knowledge that remains largely underexplored. So the answer is yes. The answer is yes. You always see this kind of positive correlation. If you challenge more, if you debate more, then you are creating either in assumptions or in findings more hidden undiscovered links between knowledge. So you're contributing to knowledge novelty. And also very interestingly, we do also observe that in soft, more like context-based knowledge, you need to debate more to create novelty compared to the more context-irrelevant hard knowledge. Using these two conferences as an example, for the empirical method of linguistic models, then people are more likely to debate, and then like more novel things are created more novel knowledge are created in there, and compared to more like context irrelevant venues of publication, people are less likely to debate, and then less novelty is created. I mean, even you think of the percentiles in terms of like the rankings, then with the same amount of debate, people looks like to create more novelty, more surprise, more unknown knowledge in soft knowledge rather than in hard knowledge. So this is like, we address these two questions in the context we just introduced, and then like provide this like very preliminary but very interesting results to you. And I will leave most of the time for the discussion so that we can unfold this very interesting topic fully. But I like to take this opportunity to acknowledge my great collaborators who also contribute to these slides and some of the results, and also have exciting projects going on. The first one is Arun Sharma from the Pitt Department of Information Culture and Data Stewardship, and what we are presenting, what I'm presenting, we are doing is highly related to a project leading by her. We try to extend we try to associate the between debate and knowledge, and then try to extend it from science to Wikipedia, and eventually, hopefully, will to social media. And the other great things going on with our group is also includes the project of analyzing 300 years history of case law in the United States. And we are looking at the millions of law cases and try to see how this kind of debate, debate not about the knowledge, but also about the values, change and structure our society, and how, for example, the abandon as a keyword as used to be a crime, but now it's not a crime anymore. And when did this happen? And how did this happen together with other values, with anchoring values in our collectively cognitive system as a law, and how the institutional things and how these things may change. So that is the great, exciting project going on with Lingfei from University of Chicago, Department of Sociology. And the last thing about the debate we are doing in science, we're looking at whole science theory evolution over more than 100 years with available data. We're looking at the 43 million articles and 10 million scholars, and see how this debate happened, how the scientific debate happened across generations. And very interesting, we found a universal aging effect that as the career age of scholars evolve or increase, then they tend to cite earlier reference. So you see that kind of thing, like people get stuck in time. Or maybe it's not always get stuck because like it's still too far, too early to jump to the conclusion whether this is totally a bad thing or it could be also a good thing. But you see how people build up their identity when they became independent after the adolescence, a little jump to cite a more recent reference, then all the way up, they kind of build up, but also get this identity, this culture and knowledge identity gets sticky, and then keep living in the world. They think they already, that's the current world, but they kind of living in the world that disconnect from the known and the frontiers of science and knowledge over time. And we also analyze the factors that can reset the innovation clock. Like if we observe that if you collaborate with young generation scientists, and if you move between institutions, this kind of jumping out of the comfort zone actions will, to some extent, reset the innovation clock and make you pay more attention to the ongoing conversation rather than living in your own frames or worlds. So with that, I will conclude my presentations, and I welcome all the questions within this session or follow up to my email. Thank you.
Thank you very much. Do we have any questions from the floor?
I can start. Thank you, Lingfei. It's a very interesting talk and also gives a positive view of what is going on currently when you look at polarization. Definitely gives an optimistic view to that mess. I had a question about the type of articles. So sometimes you have articles that bring conspiracy theories, or there is a hard to reach consensus on whether it is climate debate or whether it is vaccination versus autism debate. So has your work or someone else's work shed light on those type of articles where there is a lot of debate, but hard to imagine that there will be new knowledge created?
Yeah, that's a great question. That's also the question I keep thinking. And so there are many points, and I think the first one I'm totally agree. So right, you see people with debate, like, so you see the debates looks like never going anywhere, right? And you see people who never convinced by evidence or facts from the other sides. Actually, one phenomenon we always notice in the social media is that people using conflicting evidence as endorsement for their own statement, right? So that's also like one motivation behind the aging dynamics of what I'm doing. Like it's a lot of times it's rather than just like a debate for knowledge, but people like debate for identity. But then like when it comes to identity issues, it's very hard to completely change people, right? Because what they are talking about is really about what they think the world is look like. And so that, but with that said, with the acknowledge of that kind of debate and going on with which is hard to converge rather than progressive. I would also like to add a little bit of compliment point from that. Like whenever we see the debate that taking a lot of time to converge. Again, a very optimistic view. It's not always a bad thing, because we should notice that some knowledge, like soft knowledge here, but maybe also some other kind of knowledge, is more expensive and more complicated to obtain than other knowledge. So like to a principle towards this is what I call as the computation complexity. In computer science, this is like a dominant principle that you cannot save memory and time at the same time, right? For example, if you want to print out 1 million digits of pi, then you have two ways you can minimize your memory. You write a small program, then the program will continuously compute when they print it out. In that way, you save memory and space, but you cost time. And the other way is like you pre-compute all these 1 million digital pi and you put it somewhere in your memory. Now, whenever you want to have the 100 digits, the 10,000 digits, you can immediately print it out. In this way, you minimize time, but you consume a lot of memory. So, to some extent, I would suggest our social brain is a similar thing. You cannot minimize time complexity and memory complexity in the same time. And this revisits our small team disrupt paper published on Nature earlier this year, that we found that small teams are making more like bigger drops in terms of cognitive level. Like they disrupt existing thinkings, theories, and findings, when large teams rather prefer to endorse it, support it, develop by that from there. And another conclusion, another thing we can look from here is like small teams are paying more time complexity. They have less burden in time because they consume less money. And we all know when you have a lot of money, when you apply a lot of grants, when you award a lot of grants in science, what kind of pace of life you're living in, right? You have to keep keeping up, keep delivering things. So in that sense, going back to what we are asking, what we were talking about is like some issues may consume more time complexity. And for that issues, it probably will take a very, very long time to converge and to find answers.
Thank you, Lingfei.
I have a question sort of related to Nitin's question.
Please.
In this working group lately, we talked a lot about misinformation. And in light of the growing spread of misinformation, what are your thoughts on possibilities for fruitful public debate?
Would you like to unfold the question a little bit? What kind of public debates in terms of like what kind of context are we?
Oh, let's take the presidential election, and let's say that there's growing spread of all kinds of misinformation. Do you think that those sorts of debates have hope for being fruitful in light of that?
I do think debates will push forward knowledge and understanding, but the president debate is a complicated thing in the way that it's a media behavior, right? It's on media, and so so there are different audience over there, and a debate may not only push forward the knowledge from one group. So this is like a very interesting, but probably like more time complexity topic in way like what's the consequence and what's the function and what should be the goal of this political debates. But one consequence I can see from there is like political debates push forward knowledge to different social groups and make them acknowledge the existence of each other, right? So I see a lot of concern, and I share a lot of these concerns, like there's even ongoing polarization and then divide going on. But then I was, again, going to the optimistic point of view, I was thinking, maybe we are not more divided than before. Maybe, I mean, in a way that we measure that we always find them more, but take a metaphor, like if you live by yourself, live in your small village for thousands of years, and you probably don't know the existence of a completely different kind of social group. But now, because of social media, because of everything, it kind of extends your horizon of senses. It makes you see, or it kind of forces you to see the existence of very different kind of groups. And for that sense, your knowledge extends because you know people could be very different. So I think there are still like a positive consequence in terms of debate. Maybe it's too early to say to what extent this kind of debate may contribute to knowledge in terms of like converge ideas. But at least I do see its contribution in terms of unfolding ideas. Because science is probably, at least for the field that I'm more comfortable and more confident about, that is the science. Science is not only about convergence, it's also about unfolding. Whenever the time comes, the paradigm shifts, and it's always like people try to compress things. People have a lot of observation and the data. They want to write out equations that the shortest equation as possible to summarize everything they know. And that equation and that paradigm and that worldview will last for decades or even centuries until people find conflicting evidence. And then of course, it's always the identity thing. We are all human beings. So there comes with the conflicting evidence, there'll be new generations and the conflicting social groups. And then like groups will debate, then there'll be new paradigms that with more powerful in summarizing more complicated data in the shorter equations. And but unfolding and challenging and breaking down the existing uniform worldview is probably the cornerstone of the next step. Yeah, that's just some quick thinking. But that's a great question. Yeah.
Thank you.
So I have a question for you. When you were talking about the language that was used, that was inconclusive language, how are you measuring that?
The ambiguity?
Yeah. How are you measuring the ambiguity in the language?
Yeah, this is a great question. I'm glad that you asked. So there are like multiple ways, and cheap but dirty way is you select. For example, if you have this word investigate, and then we identified I'm speaking for the authors. I'm not the author of this paper though. So we identify its alternatives. For example, study, exam, analysis. So these are three alternatives of the word investigate. Now we will select all the sentence with this word, one of these four words as contains these words. Right? And then like we'll identify the sentence, basically like in a very strict standard, we can just select all the sentence with only this word change. For example, a sentence is like, we investigate data. Now we select this sentence. Now, whenever next time you observe the sentence like, we study the data, or we examine the data, or we analyze the data, then we select all these sentences and we put them together. For example, there are 100 cases, and then 30 of these 100 cases is using investigate, and then 19 is using study, 6 for, sorry, that doesn't sound like 100, but basically that's roughly the example that you have different frequencies attached to different words. Now you can calculate the entropy or the variance or variance, anything you like, to quantify the concentration of weight in this particular word. For example, in mechanical, we probably cannot even identify any context used exchangeably with other words. But for the investigate example, you identify a lot of same contents, the same context they used, but with a replaced word. So that's a way to measure in the naive but dirtily. There are also other ways that I am developing using neural network embeddings in a way that we can use this neural network to identify language complements or substitutes. For example, Oxford University and Cambridge University, they are substitutes because people use people talk about universities and good universities to go to in England. So they kind of occupy a similar position in the context. But then like Cambridge University and expensive tuition fee, these are not substitutes, these are complements because they are dissimilar with each other, and that you have to put them together to form a meaning, to make it functionable. So there are word embedding techniques to identify these kind of complements and substitutes of words in a more broader, more set of contexts. But what they are doing as author in this paper is really just identify all the context, calculate the weights, and calculate the concentration.
I see.
Mhm.
Okay. So, I mean, word embeddings are extremely computationally intense in some sense.
Mhm.
So, if one wanted to scale this up, do you have any suggestions for how it could be scaled up so it could be done with a way that was not so computationally intense?
Yeah, in terms of, so the way they developed in this paper is, I will argue is even more handcraft and computational. I mean, in terms of algorithm, it's easier, it's simple, right? It just identify all the words, all the sentence and then calculate the words, but it's very handcraft. You have to identify the words you want and identify all the alternatives and then identify all the, but I would probably suggest that word embedding is actually, compared to this method, if we want to scale it up to millions of documents or 10 millions, it's probably easier because all the computation power goes to inferring the embedding for words so that they have their positions in the hidden space such that by analyzing their vectors, you can quantify this kind of complements and substitute already. And you don't need to have a very strict standard of what is context, how to identify sentence and words. Yeah. And just add one more point, there are, if it's too much for the research group to train word embeddings in a satisfying performance by themselves, there are available open data sets. So one available data set is the word embedding provided by Google through Google News. So that's trained on a very huge amount of data, and they provide a long list of 1 billion words. Each word is represented in 300 dimensions. And by analyzing that data set that share the parameters is also a cheap way to identify word complements and substitutes. So it's like the famous woman minus man plus king equals queen example. You can identify these hidden dimensions by gender and power, and then like see how replaceable or use interchangeable two words are.
Thank you. Do we have any things on the line that were typed in?
I will assume that will be my talk already, and I really appreciate the opportunity to come, and I welcome all kind of following questions. Yep.
Thank you, Lingfei. Kathleen, just to answer your question, I don't see any messages on the chat window. Marian, do you all see the same?
Yeah, I see the same.
Thank you.
Okay, thank you both. Thank you very much, Lee. And we look forward to having you join future meetings. Take care.
Thank you. Take care. Thanks, everyone. Bye.
Thank you, everyone. Thanks again, Lingfei.